graphing help you solve a system of linear equations? Think about this question during the lesson. Lee is choosing a new cell phone plan. She has narrowed it down to these two plans. How can she use the graphs of a system of linear equations to determine when the phone plans cost the same? Which plan should she choose? You can use the graphs of a system of linear equations to compare the costs of each plan. Let's begin by writing a system of equations. Her total monthly cost of a plan is equal to the cost of the number of minutes she uses plus the cost for unlimited data. Let X equal the number of minutes used each month. And let Y equal the total monthly cost of the plan. The equation for company A is Y is equal to 20 hundredths times X plus 75. The equation for company B is Y is equal to 25 hundredths times X plus 70. This is our system of equations. Now, we can graph the system of equations. The lines intersect, so there is one solution for this system of equations. What does the intersection point, 195, show about the two cell phone plans? This intersection point shows that if Lee uses 100 minutes each month, both plans cost $95. She could choose either plan. If Lee uses less than 100 minutes, which plan should she choose?
Select your answer.
If Lee uses fewer than 100 minutes, she should choose company B because the monthly cost is lower. If Lee uses more than 100 minutes, she should choose company A for the same reason.
Solve the system by graphing. Y equals 3 times X plus 5. Y equals 2 times X plus 4.
All right, so I'm going to use this graph. I like to start with using the y-intercept of the equation. So our y-intercept in both equations will be found here. So the first one is 5. So I'll make the orange the first equation. So there's my y, 5, and then for the second, my y is 4, okay? Now, the number in front of the x is your slope, and we're going to use them to find the other points on the line. So with the first equation, our slope is 3. It's a whole number, but a way to write a slope, another way to write a slope could be a fraction or decimal. So if the whole number 3 were as a fraction, it'll be 3 over 1. So it'll be, rise over run. So for the orange line, I'm going to start from my y-intercept, and just because the line is going downward this way, instead of rising, I'm going to go down. So I'm going to go down 3. So 1, 2, 3, and then I'm going to run to the left 1 space. So that's there. And then I can also go up. I can rise 1, 2, 3, and over 1, so that I know that my line is in the right place. For the blue line, our slope is 2, so it'll be 2 over 1. So I'm going to start at my y-intercept. I'm going to go down 1, 2 spaces and go to the left 1. So my line should be going right about there. And I'm just go rise 1, 2 over 1. So I just want to move this over just a little. So double check that. So we got 1, 2, and then 1. Good. And then we have 1, 2, then over 1. Okay. So it's kind of off just a smidge, but this is the point where they intersect. So the points where they intersect, or the solution, right? The point where they intersect would be this point here, which would be -1, and my y would be +2. And that is how you would find a solution to the system of equations.
Solve the system. Y equals x minus 4. Y equals x minus 1.
Graph the equations of the system to determine the solution. Click on each equation, to show its graph. So this is the graph for the first equation. This is the graph for the second equation. With both of the lines on the graph, you can see that they are parallel, which means there's no point of intersection. They will never cross each other. So for this particular equation, there's no solution because they will not intersect. So the system has no solution.
Find the approximate solution of the system. Y equals 1 25/100 times x plus 2 3/10. Y equals 23/100 times x plus 1.
We're going to estimate the x and y values at the point of intersection. So here's the point where these two equations intersect. So it's approximately 1 3/10 and 0 7/10. And that's because the x value, if you look here, is past the -1, but not quite at the halfway mark. So you approximate that 1 3/10. And then for 0 7/10 on the purple, for the y, our y here is about, it's not quite to the 1, but it's past the halfway. So they approximated that 0 7/10. So because it is an approximation, it's not the actual. It's almost like an estimate.
Solve the system by graphing. Part A. Y equals -5 times x minus 3. Y equals -1/3 times x plus 2. Describe the solution.
We're going to start by graphing the y-intercept. So for the first one here, our y-intercept is -3. So that'll be here. And the second equation in blue, our y-intercept will be 2. Okay. So now, again, we look here for the first equation and we have our slope at -5. And then again, rise over run, and that's a whole number. So it'll be rising 5 and running 1. So we're going to go, because it's negative, we're going to go down 1, 2, 3, 4, 5, and then over 1. So I'm going to put this here. Okay. And then we're going to look at our blue. Our y-intercept is already there, so we're going to go down 1 because it's 1/3. So we're going to go, when it's negative, so we're going to go down 1 and 3. 1, 2, 3. Okay. So these are the point or graphs for the equations, and then we have to find the solution. So our solution is where they intersect. So again, we're going to approximate. So our x here would be just a little before the halfway. So let's go with our x being negative 1 and 3/10. And our y would be it's kind of a little before the halfway for the y as well. So we'll do positive 2 and 3/10. And again, these are approximations, not exact. So these are my approximations of the solution of this equation, these two equations.
Solve the system by graphing. Part B. Y equals negative 1/3 times x plus 7. Y equals negative 1/3 times x plus 2. Describe the solution.
So we have the same equation we had before for the second equation. So I'm just going to put it back real quick. Use the blue. So my y-intercept is at 2. And then my slope is down 1 over 3. 1, 2, 3. Down 1, 1, 2, 3. There we go. And sorry, other side. There. Okay, so then we have the first equation. We have to graph that y-intercept is 7. So positive 7. So we're going to go positive 7 here. And then our slope is actually the same. So we're going to go down 1 to the right. 3. 1, 2, 3. About there-ish. Okay. And so these lines seem to be parallel. And because they are parallel, they will never intersect, which means there will be no solution.